Hello students, today we're going to be talking about solving one-step equations, and we're on page 21 in our composition book. So before we get started with the lesson, I need you to copy this chart down in your composition book, again on page 21. So I'm going to put it there for a second and then you can pause the video to copy it down. Now that you have that chart copied down in your composition book, we're going to continue to talk about solving one-step equations. Now the goal in solving a one-step equation is to isolate the variable. So will you please write this under the chart that you just wrote down? We need to isolate the variable. What that means is everything else got to go. With a capital got to go. All numbers, anything except the variable got to go to the other side. So remember that phrase, isolate the variable and everything else got to go. The way we isolate the variable is using the opposite operation. So for example number 1, if we have the equation y plus 3 equals 10, we know that our variable is y and we need to get y by itself or isolate it, and everything else got to go. Well, to get rid of the 3 we have to do the opposite operation. Right now it's being added, so the opposite of that is subtracting, and we're going to write it just like this. And the rule in math is what you do on one side of the equation, you have to do on the other. So we're going to subtract 3 from the other side. The 3's cancel out, so we're left with y equals 10 minus 3, which is 7. Now if I take that 7 and plug it back in, 7 plus 3 equals 10, so I know my equation is correct. And the second example, and please write it next to in your composition book because of the way we're doing this. What if I have negative 3 equals x plus 2? Now, even though the order is a bit different, that's not a problem. We still need to isolate the variable. That means we need to get rid of the 2, or actually move the 2 to the other side. And to do that, we're going to subtract it. And we have to subtract it from both sides. So we know that x equals negative 3 minus 2 is negative 5. And now we're going to look at example number 3 and 4, which have to do with a subtraction equation. So if we started with t minus 9 equals 11, to get rid of the 9, we have to move it to the other side or add 9 to both sides. So if we add 9, I don't need that equal sign. The 9's cancel out because negative 9 plus 9 is 0. T equals 20. And we can bring it back in. Is 20 minus 9 11? Well, yes. And so the next example we're writing in our composition book is 14 equals r minus 7. Since r is our variable, we need to isolate it. That means we need to do the opposite of minus 7, which is plus 7 on both sides. So 21 equals r. Even though you may have space on page 21, let's go ahead and flip to page 22, and we're going to write continued at the top because we're continuing to talk about solving one-step equations. Now let's look at some multiplication problems. If we have, for number 5, 8x equals 56, you know that anytime you have a number right next to a variable, that's multiplication. So the 8 is being multiplied by whatever x is. In this case, since multiplication is the operation, then the opposite of multiplication is division. So we have to divide by 8 on both sides. And again, I want you to write it just like this, and we need to practice writing it like this. Well, the 8 divided by 8 is 1x. We don't write the 1, we can just write the x. And then 56 divided by 8 is 7. And let's look at example 6. Which would be 39 equals 3x. Again, our variable is x. Sorry, I had to move the camera. Our variable is x, and we need to get the x by itself. The operation is multiplication, so I do the opposite. The opposite is division, so we divide by 3 on both sides, remembering that that fraction bar also means divide. So 39 divided by 3 is 13. The 3's cancel to 1, x. So x equals 13. And now we're going to get to our friend's division. So there's 7. We're going to do a divided by 5 equals 12. Remembering that this line means to divide. So to get a by itself, or to isolate a, we have to do the opposite, which is to multiply. So we're going to multiply by 5 on both sides. Now here's where it gets a little tricky in the writing it down. Since I'm going to multiply by 5 on both sides, I'm going to put 5 times a over 5 equals 12 times 5. Now when we multiply by a whole number, we can turn that into a fraction. And we have 5 over 1 times a over 5. Well, you remember from multiplying and dividing fractions that I can cancel any denominator with any numerator, and those become 1s. And so all that's left is 1a. Well, we don't write the 1, we just write a. Equals 12 times 5 is 60. Now let's just check it. If we put the 60 where a is 60 divided by 5 12? Yes. And so the next example, number 8, is going to be negative 13 equals b divided by 4. And once again, we have to do the opposite operation. So we're going to multiply by 4 on both sides. So 4 times negative 13 equals b over 4 times 4. And again, we're going to put it over 1. Now to multiply these, we can cancel any numerator with any denominator. And we're left with 4 times negative 13, which equals negative 52 equals b. Draw a squiggly line now under those problems, and we're going to separate this into fractions. What do we do when we have fractions in our problem? For instance, let's say we have negative 3/8 m equals 21. Well, my operation is still multiplication because we have the variable times a number. It equals 21. But let's remember with fractions. If I wanted to divide by 3/8 on both sides, I'm going to write this over here. Dividing by 3/8 is also the same as multiplying by the reciprocal times a over 3. So if we remember that dividing by 3/8 is the same as multiplying by 8 over 3, I'm going to multiply by 8 over 3 on both sides. So negative 8/3 times negative 3/8 m equals 21 times negative 8 over 3. Now the negative 8s and the 3's cancel out, and we're left with m equals, I'm going to put 21 over 1. We can cancel this 3 and the 7. The 3 divided by 3 is 1. 21 divided by 3 is 7. And so all we're left with is negative 56. We'll go over some more problems like that in class in case that's confusing. Now that you have watched the video, please send me the answer to these 4 problems via Edmodo, but send it as a direct post to me, not the entire class. This will be graded, and you will receive a grade for sending it to me, and we'll go over the answers in class.